Hello student, in this video we will learn about moment of force and center of mass, stability and equilibrium. Turning effect of force. So before discussing turning effect of force, what is a pivot? Let's understand. A pivot is a point, shaft, pin, etc. on or around which something turns. Like in scissor, this pin is called pivot. And in rotating door, here is the pivot around which the door rotates. So what a force can do? When force can make an object turn around, we say that force have turning effect. When we apply force on the object in such a way that an object starts moving about a pivot point, then the cause of this movement is due to the turning effect of force. Examples of turning effect of force. Application of force to a spanner to rotate a nut, turning a steering wheel by applying a force on its rim, lifting a load in a wheelbarrow, and in opening or closing a door, a force generates turning effect. The moment of the force. The quantity that tells us about the turning effect of a force is its moment. So how we define a moment of force, how we calculate? Moment of force is equal to force multiplied by perpendicular distance of the pivot from the line of action of the force. What is the line of action of the force? The line passing through a point of application of a force and along which a force acts on an object is called a line of force. Here we can see that moment of force will be force F, the magnitude of force F, multiplied by the distance x1. x1 is a perpendicular distance of the pivot from the line of action of force. This green line indicates the line of action of force. Here force is applied at point A. In this case, the moment of force is defined as force multiplied by this perpendicular distance x2. x2 is a distance of pivot from the line of action of the force and it is a perpendicular distance. So the moment of force depends on two quantities, the magnitude of the force. The bigger the force, the greater its moment, and the perpendicular distance of the force from the pivot. The further the force acts from the pivot, the greater its moment. Moment of force is called as torque also. So torque is a twisting or turning force that tends to cause rotation. In this case, the force F3 will produce the biggest turning effect because it is acting perpendicular to the object and its distance is more as compared to the other two forces. Balancing moments. When the moment of the force makes a body to rotate in clockwise direction, it is called clockwise moment of force. And when the moment of force makes a body to rotate in anti-clockwise direction, it is called an anti-clockwise moment of force. Thus, when there is no rotation, the algebraic sum of the total clockwise movement about an axis must equal to the algebraic sum of the total anticlockwise movements about the same axis. This is known as principle of moments. So, according to principle of moments, total clockwise movement is equal to total anticlockwise movement. Here, three children have balanced the seesaw. So, this system is in equilibrium. And the principle of movement now we can apply to check whether an object will remain balanced or start to rotate, or we can calculate the unknown force or distance of force from the pivot if we know that the object is balanced. So if we calculate here the anti-clockwise movement, it is 500 multiplied by 2 force and the perpendicular distance from the pivot it is 2. So the anti-clockwise movement is 1000 Newton meter. Clockwise movement is equal to these two force will help in clockwise movement. Force multiplied by perpendicular distance plus force multiplied by perpendicular distance from pivot. 400 multiplied by 1 plus 300 multiplied by 2. So it is 1000 Newton meter. So we see that clockwise movement is equal to anti-clockwise movement, so we can say that system is in equilibrium. Equilibrium of a rigid body. The following conditions must be satisfied if an object is in equilibrium. The resultant force acting on the object must be 0 and the total clockwise movement should be equal to total anti-clockwise movement. Here this is a force diagram for the seesaw shown here. The upward contact force of the pivot is equal to the total downward force. It is 500 plus 100 plus 400 plus 300, and 100 Newton is the force of pivot itself. So the upward contact force of the pivot balances the downward forces of the children's weight and the weight of the seesaw itself. The contact force has no movement about the pivot because it acts through the pivot, and the weight of the seesaw is another force that acts through the pivot, so it has also no movement about the pivot. Equilibrium. Equilibrium can be classified as static equilibrium or dynamic equilibrium. In static equilibrium, when the physical state of a system is at rest and the resultant force or torque is zero, then we say that the system is in static equilibrium. In dynamic equilibrium, the physical state of a system in a state of uniform motion and resultant force and torque on the system is zero, we say that system is in dynamic equilibrium. So in dynamic equilibrium, the system will move with constant speed because it is a state of uniform motion. So equilibrium can be further classified as stable equilibrium, unstable equilibrium, and neutral equilibrium. In stable equilibrium, if a system is disturbed slightly and it continues to be in its original position, then the system is said to be in stable equilibrium. A book lying on a horizontal surface is an example of stable equilibrium. If the book is lifted from one edge and then allowed to fall, it will come back to its original position. Unstable equilibrium. If a system is disturbed slightly and it is taken away from its equilibrium position, then the system is said to be in unstable equilibrium. Example, an egg balanced on its longer axis and a cone standing on its vertex at top is an example of unstable equilibrium. Neutral equilibrium. A system is said to be in neutral equilibrium if it is disturbed slightly and it does not come to its original position, but in new position it maintains its state of equilibrium. For example, a ball lying on a table and an egg resting on its smaller axis is an example of neutral equilibrium. Center of mass. The concept of center of mass helps to study the mechanics of many particle systems. When we calculate the effect of force on any object, we assume that the force acts at a single mass point and that point is called center of mass. Center of mass is the point at which the whole mass of a body is supposed to be concentrated. It is a point at which the distribution of mass is equal in all directions. The position of center of mass of a body depends on shape, size, and distribution of mass of the body. The position of center of mass does not depend on gravitational field. The center of mass does changes when an external force acts on the body. For example, when the human being is standing or bending, the position of center of mass changes. Thus, the center of mass can be changed by bending the object, reshaping it, stretching or compressing it, by changing the density or by changing the mass distribution. In all these three positions, the location of center of mass changes because with every new position, the distribution of mass changes. Finding the center of mass for symmetrical bodies. For symmetrical bodies of uniform densities, the center of mass is the geometric center of the object or lies somewhere on the axis of symmetry. Center of mass may be located outside the physical bodies. This is the case with hollow or open-shaped bodies. How to find center of mass for irregular shaped object? Let's take a piece of cardboard of irregular shaped. Now take a lamina with 2 or 3 holes near the periphery of the lamina and suspend the lamina through them one by one. Attach a length of a spring to one of the holes. The other end of the string has a heavy mass attached to it. This arrangement is called a plumb line arrangement. When the object stops swinging, draw a line along the vertical string of the plumb line. Repeat the process with different holes. The center of mass will be at the point of intersection of the line drawn on the object. Center of gravity. Center of gravity is the point at which the whole weight of a body is supposed to be concentrated, or we can say that whole weight of a body is equally distributed in all directions. The position of center of gravity depends on gravitational field. So the center of mass and center of gravity of an object are in same place, same position if the gravitational field is uniform. But if the object is placed in a non-uniform gravitational field, then the center of gravity will shift toward the greater field strength. Let's suppose that object is placed in a uniform gravitational field. This is the pictorial representation so that you can understand that any object is placed in a uniform field. Gravitational field is uniform around the object. So the center of mass and center of gravity coincides. The position of both center of mass and center of gravity coincides. They are at the same position in the object. But if the object is placed in non-uniform gravitational field, and let's suppose the field is more intense toward the base of the object, so the center of gravity will shift toward the greater field strength. Here the center of gravity is somehow below to the center of mass. So by using the center of gravity, we can balance any shape of an object against the gravity. Thus it helps to maintain stability. Stability. What is stability, or how to define stability? Stability defines the virtue of an object to maintain its stable equilibrium, to maintain its balance. The stability of an object is strongly dependent upon its position of center of gravity. The lower the center of gravity is, the more stable the object. The higher it is, more likely the object to be unstable from its original position if it is disturbed. Here we will discuss what happens when the glass is tilted. When the glass is upright, its weight acts downward. Let's assume the glass is placed on a table and the contact force of the table acts upward. So the two forces are in line and the glass is in equilibrium. If the glass is tilted slightly to the right, the forces are no longer in line. What happens? That this point where the base of the glass is in contact with the table will act as a pivot, and the weight of the glass is toward the left of the pivot, so this weight produces an anti-clockwise movement. Since we are tilting the glass toward the right and the weight produces an anti-clockwise movement, so this weight tends to tip the glass back to its upright position and the glass will come to its original position again. Now if the glass is further tipped, its weight acts to the right of the pivot. So the weight produces a clockwise movement, and we can also see that the vertical line through the center of gravity, the weight acts to the center of gravity, and the vertical line through the center of gravity does not fall within its base. This line is out of the base. While in previous two conditions, the line passing through center of gravity lies within the base, we can see, but in this case the line is out of the base, so it will topple over. The glass will not retain its equilibrium position, it will topple over. Thank you very much for watching this video. I request you to please pause video, read all the definitions written here, and also write your feedback in the comment section. Thank you very much once again.